So let us do another problem from chapter 1, your textbook example 1.5. In the new textbook it is example 1.5. In the older textbook it is 1.6. Okay. So let us read the question. Consider three charges Q1, Q2, Q3 each equal to Q. So Q1, Q2, Q3 each equal to Q at vertices of an equilateral triangle of side L. This is an equilateral triangle of side L. What is the force on the charge capital Q with the same sign as that of small q? So small q's are positive. So the capital Q is also positive. Placed at the centroid of the triangle as shown in the figure. So this is the centroid of the triangle. So the charge capital Q is placed at the centroid of that triangle, equilateral triangle. So we have to find the net force on that capital Q charge. So here we are applying the concept of superposition. Coulombs law obeys the principle of superposition. Okay. So we will be finding the force on capital Q due to each charge. So we will find force on capital Q due to A, force on capital Q due to B, force on capital Q due to C. The basic Coulombs law application. Now coming to the distance between A and Q. Q is at the centroid. So centroid of an equilateral triangle is at a distance of L by root 3. That you should know. If you have an equilateral triangle of side L, then the centroid O will be at a distance of L by root 3 from each vertex. Okay, so you will be getting the distance as L by root 3, and then you have the charges. So first we will find the force on capital Q due to the charge small q at A. Now, what will be the magnitude? Magnitude will be K Q1 Q2 by R square, right? So K Q capital Q by R is what? L by root 3 the whole square. K Q capital Q by L by root 3 the whole square. Root 3 the whole square will be 3. So moving to the numerator, 3 K Q by L square. Now what will be the direction? Force is a vector quantity. So we just got the magnitude. We should know the direction also. How will you find the direction? Just check the sign of the charges. Here both charges are positive. Like charges repel. So force on Q due to A, it will repel. Force on capital Q due to A, it will repel. So repel. The capital Q will be repel. So this is plus Q. This is plus capital Q. The force on this due to this will be what? Repulsive force. It will repel. So the force direction will be along OA. Sorry, AO. This will be the direction AO. The repulsive force direction. Okay. Now, so the magnitude is 3K QQ by L square along AO. Okay. Now we got the force on capital Q due to A. Similarly, we have to find the force on capital Q due to B. Force on capital Q due to B. Same. The magnitude will be the same. K QQ by L by root 3 the whole square. It will become 3K QQ by L square. And what will be the direction? Here again repulsive. So from B to O, that direction. So F2 direction is BO, along BO. Okay. Similarly, force on capital Q due to C. Direction is repulsive. Direction will be CO. Magnitude will be what? KQQ by L by root 3 the whole square. So when you see the magnitude, all the three magnitudes are the same. Force on capital Q due to A, force on capital Q due to B, force on capital Q due to C. All the three magnitudes are the same. So I'll just represent it using F for simple representation. Okay, so that the calculation will be easy only for that purpose. Finally, I will substitute if required. So, since all the three forces acting on capital Q due to A, B, C are same, I will represent it with capital F. Okay, now let us see the forces. We understood the force due to A. F1 is in this direction. Force due to B, F2 is in this direction, and force due to C, F3 is in this direction. Now, if the forces are acting on the same line, then we can either add or subtract. So here the forces are in three different directions. So it is difficult for us to add or subtract. So we will use the concept which we studied in grade 11, the resultant of forces. Okay, so here we will find the resultant of any two of the forces. Okay, so if you think about the resultant of F2 and F3, here I will find the resultant between F2 and F3. What is the formula? Parallelogram law of vector addition. We find the resultant using that law. What was that? If vector A, what was that if? I'll just show it over here. You studied in grade 11. You have two vectors A and B with an angle theta between them. Then the resultant will be given by root of A square plus B square plus 2AB cos theta. So here you have two vectors F2 and F3. So F2 square plus F3 square plus 2F1 F2 cos theta. You have to find the angle between them. Coming to the angle between them, this being an equilateral triangle. This is an equilateral triangle. So centroid like this. So this angle is 30. This angle is 30. This will be 90. Now this is also 30. So what will be this angle? This angle will be 60. Similarly, this angle also 60. In this triangle, this is 90, this is 30 and this will be 60. Understood the concept? Just check. Think about this particular triangle. This angle is 90 degree. Centroid, right? 90 degree. This will be 30 degrees. So angle sum property 90, 30. So the third angle should be obviously 60. So this is 60. This is also 60. So what is the total angle between force F2 and F3? 60 plus 60, 120. Okay. So you got this angle as 120. Now you will apply that 120 in the resultant formula. Root of F2 square plus F3 square plus 2F2 F3 cos 120. We know F2 and F3 are equal. Instead of substituting this bigger value, we just substitute it as F. So the simplification will be easy only for that purpose. F square plus F square plus 2F square cos 120 is minus 1 by 2. So 2 to cut. F square minus F square will go root of F square, which is F. So what will be that? The resultant of F23 will be in this direction. See? And the magnitude will be what? F itself. So now which all are the forces acting on that capital Q at the centroid? Force due to A, which is F1, which is acting down, and the resultant force acting up, and the magnitude is same itself. We got the magnitude of the resultant force as F. So capital F acting down and capital F acting up. So what will be the net force? Net force will be 0. The net force acting at the centroid will be 0. So this is an application of superposition principle. These type of questions are important. Lot of questions are there. Triangle questions are there. Square is there. Okay, so this concept is important, and always remember this in between the problem. Sometimes you will have to apply this resultant concept as well. Hope it is clear. Go through the question, okay.